Assalamu alaikum. Welcome to the first lecture of chapter 6. Chapter 6 is mechanical properties of metals. Let me remind you a couple of things. I am giving these chapter numbers according to my lecture scheme, right? They are not exactly the same chapter numbers as in the book of Callister. If you have issued the book of Smith and Hashmi, then the chapter numbers may match. But if you have issued the book of Callister and Rathwish, then the chapter numbers may not be exactly the same. But the chapter on mechanical properties, the first chapter, will be the chapter on mechanical properties. In my lectures, I am calling it chapter 6. This is one thing. The second is, your obvious question should be that after chapter 1, why are we jumping to chapter 6? So chapter 2 is about atomic structure and similar things, because all material properties and all material structure is based on atomic structure and molecular structure and so on. So in a good book on material science, they do not assume that you already know it or not. They give that chapter. But of course, you have done that many times. You have done it in Sanvia, the basic atomic structure. Then you have done basic chemistry and basic physics here in the university. So that chapter we are not covering in the course. That is a background. From chapter 3, real material science starts. But chapter 3 is about crystal structure. And I think I told you at the end of the last lecture also that we could start with chapter 3 with crystal structure as the basic fundamental first chapter of material science. But what I always like to do, I feel, right, that the message that why are we doing material science if we are going to be engineers, whether mechanical engineers or electrical or chemical or petroleum or civil or whatever. If we are going to be engineers, then why are we doing material science? Because we want to use materials to design and manufacture different products. This is it, isn't it? Whichever thing you are doing, whether you are making a computer or a civil structural building or a completely mechanical bicycle, whatever you are doing, you have to use materials to correctly and properly design and manufacture some product. So what is the most important thing about materials that we should know? Their properties. Their properties. How do the materials behave under different kinds of forces and temperatures and other environment? So that if I know the properties of a particular material, then I can select a good material for my product, right? So this is the basis. Now, this chapter 6 is about mechanical properties. All right? I can remove the word mechanical. It will be just properties. That will be later. But this is about mechanical properties. So this is where I want to start. Though in the scheme of the book, this is 6th chapter. They want you to understand the basic science of materials first. But this is sort of the science of materials and the application, because why should we know these properties? They are important in selection of the material for good design and good manufacturing. So therefore we have jumped it, right? So this brief background that why are we jumping here. Now, why are we saying mechanical properties? You try to answer me. Why are we not saying properties of materials? Right? There are two questions in the heading. It says properties of metals. It does not say properties of materials. Why is that? Anybody? So you see, whenever I ask a question, you should pause my video lecture and try to answer it yourself if you really want to interact with me and really want to understand. So why properties of metals? Why not properties of materials? We want to do properties of materials. But but materials is a large, huge field. So as an example, we take only one class of materials. We told you last time, right? Metals and polymers and ceramics and so on. One class of materials. But that class of materials, if I understand the properties of this class, then I can understand the properties of all the other classes. This should be the first requirement. And second, this should be the class of materials, which is the most commonly used material in engineering. So then it will be good, right? Why not properties of materials? Right? So the answer is that first, because materials is a very large family, and if we discuss the properties of all of them, then it would be too long and too large. So we have to select any one category or type of materials and then start. So which type? The type which is the most common in all the world of engineering. And we have discussed it in chapter 1, introduction, that for the last 4,000, 5,000, 6,000 years, since man started using materials for engineering, not using materials for food and so on, that is different. The materials that are there in engineering, right? The first wheel somebody made, the first knife somebody made, the first sword somebody made, right? Materials for engineering applications, and we have agreed that metals is the single largest category. So this is one answer. Why properties of metals? Second, why not properties of metals? Why mechanical properties of metals? So you see, there are lots of properties. There can be electronic properties of materials. There could be optic properties, right, of materials related to light and so on. There could be magnetic properties of materials. So when we say properties of materials, then electrical properties, magnetic properties, optical properties, there could be many types of properties. So again, if we talk of all properties of materials, then we will have to discuss a lot. So in the beginning, let us focus the discussion on the properties that are most important for engineering. Engineering means selection of this material for design and selection of this material for manufacturing. So in regard, the properties called mechanical properties are the most important, right? Not optical properties. Optical properties is how will it behave if we make a lens out of it, if we use it to make a telescope and so on. But if I want to use it to make a body of my phone, body of my phone, body of my computer, body of my laptop, what if I want to use it as a gear, as a bearing, as a shaft? So if I want to use materials for general mechanical products, right, then mechanical properties. So you see, just in the heading, we have spent so much time. Now I am just repeating here the few remaining slides of chapter 1 that were there in the introduction. I left them as a reading assignment for you. Remember, right? The last few. So that is just a reminder that please do not forget that. If you just listen to my videos and do not cover the 4 or 5 slides that were left at the end of chapter 1, which was your reading assignment, then some questions on the quizzes and exams you may not be able to answer. And now I am saying the same thing which I said earlier, that chapter 2 is about atomic structure and bonding. This is about basic chemistry and physics. So you can have a quick, this quick reading assignment does not mean that I will ask any questions from chapter 2. No, I will ask no questions from chapter 2. But I am saying quick reading assignment because you can quickly go through it and see if there is anything which you want to remember from your earlier courses. Chapter 3, as I told you, is about crystal structure and crystal geometry, and we will definitely cover it. But first I wanted to come to chapter 6. Chapter 4 is solidification and crystalline imperfections. This also we will cover because this is basic part of what are the defects at the crystal level, which we will cover it later. Chapter 5 is thermally activated processes. Now, because you always do a course on thermodynamics and you actually do thermo 1 and thermo 2, and then you do a course on heat transfer. So therefore, though in the book they feel that thermal related properties and so on should also be covered, but we are not covering here in this course. We are covering more on the mechanical related properties so that you can design and so on, but thermal related we are not covering, right? So chapter 1, 2, 3, 4, 5 we have talked about it. So now chapter 6. Now chapter 6, 6.1 in the Hashmi book is processing of metals and alloys. How are metals and alloys made? I have talked to you so many times that from iron ore to steel, from aluminum ore to aluminum alloys, how do we do it? Shortly we have talked about it. Now you will have a full course of manufacturing. So this part is more related to manufacturing. Therefore you will cover it to some extent in the course on manufacturing, that how are metals and alloys made. Once they are made, once they are ready, iron, steel, aluminum, this, that, then how do we use them in engineering is what we want to do. So 6.1 we are not covering, we are straight away going to 6.2. So this is it, right? So now I am just giving you an example. Design, manufacturing and material selection. This you have already done, right? This is an example which you did in the last slides. But I am just reminding you that proper material selection is a key ingredient of design. As an example, we are taking material selection for the frame and forks of a bicycle. For the frame and forks. You see, this part, not the wheels and so on, but all this part. So you have done it earlier. That the material must be strong and stiff and corrosion resistance and lightweight. Why? It should be strong to support the load without the yielding or fracture of the structure. It should be stiff. Its Young's modulus or stiffness should be high to resist excessive elastic deformation. It should of course be corrosion resistant, and it should be light in weight, right? So these are some of the basic properties that you do from a material selection viewpoint. So proper material selection process must consider strength, stiffness, weight, component shape, etc. if we want to see what material should we select for this portion of the bike. And this is the same old slide from chapter 1. If you select steels and steel alloys, they will be low cost but heavy. Corrosion resistance will not be high because they corrode. If you take wood, it will be light and strong, but it cannot be easily shaped into all the shapes. If you take carbon fiber reinforced plastic, it will be very light and strong. There will be no corrosion, but it will be very expensive. If you take aluminum alloys, they will be light, moderately strong, they will be corrosion resistant, and they will be more expensive than steels and so on. If you take titanium and magnesium alloys, they will be a little better in properties than aluminum alloys but more expensive. So therefore, except wood, all of the other steel, carbon fibers, aluminums, titanium and magnesium, all are good options. So what should we do, right? So therefore, if cost is important and general properties should be good, steel is very good. But if the properties are very important, you want to make it a racing bicycle and the cost is not an issue, then select carbon fiber reinforced plastic. So you see, we have many choices of materials which can be good for a product. But exactly what type of properties, exactly how long a life we want in our product, and how much are we ready to spend. You see, when we drive a car, you can drive a Kia, right? Or you can drive a Chinese Geely, or you can drive a BMW and Lexus, or you can go and do a custom made car like a Rolls Royce. You are still driving, you are still on the road. So most of the functions are satisfied by all of these cars. but then the cost and how high properties you want. So this was an example just to tell you that.